All right, great. Thank you for the intro as well. Hi everyone, Václav Hasik. I'm the program director at Building Transparency, focused on any of our methodology behind the tools that we own and manage as Building Transparency. I have a background in civil and environmental engineering. I also worked for an architecture firm for a little bit here in Timberlake, and then also as a sustainability consultant, working on LEED certifications, but always mostly focused on building level LCAs, but also I've done a lot of product level lifecycle assessments. I'm happy to be here. Katie, would you like to introduce yourself?
Sure. Hi, everyone. I'm Katie Poss. I am our Director of Policy and Procurement here at Building Transparency. I've been with BT for about a year. Previously spent some time with the National Ready Mix Concrete Association and also with Turner Construction. So I've been trying to attack this problem of embodied carbon in the built environment from the perspective of the contractor, manufacturer, and now from the tools and data perspective. But happy to be here, and I'll hand it back to you, Václav.
Great. And as you could tell from the title of this meeting, it's mostly a boot camp on LCA and EC3. So it's going to be highly an interactive walkthrough of both of those tools. I will also start with a basic overview of these tools and how they fit into the general design and construction workflow. And we did also want to highlight the Epic tool as kind of the best probably starting point for early design planning if you're trying to span the whole design and construction process. So with that, a little bit about us as Building Transparency. If you don't know too much about us, we are a nonprofit organization based out of Washington State. Our team is actually scattered around the country, so we have representations around the country, and we are usually part of local CLF hubs as well. So you might run into us sometimes in various regions around the country. We do have primarily, or we started with the embodied carbon and construction calculator tool, EC3 tool, but we've also taken over the further management and development of the Tally LCA tool, which we'll go over today. And then we also have what's called the Tally Climate Action Tool plugin, which is basically a Revit plugin for EC3. It's just highly inspired by the Tally LCA tool itself. Again, we are a nonprofit organization, so none of our work really would be able to be done without the support of some of our partners, both technological, expertise on specific topics, but also the financial support of being able to develop some of our tools for low cost or no cost at all. I just wanted to thank everyone on this list. Now let's go over the basic overview of how you can use some of these tools in the design and construction process. So in the early planning stages, you can use some of the whole building LCA tools like Tally LCA, Athena Materials Institute, Impact Estimator. But most recently, there has been the Epic tool, which is really focused on helping you try to evaluate the potential carbon footprint projects very early in design when you only know basic aspects of the building, such as the building type, building size, number of floors, structural systems, etc. So you can really start getting a broader idea of what the overall impact of the building may be during the conceptual phase using this Epic tool. And again, I'll quickly introduce it before we dive into the other demos. Then as you go into the schematic design and design development, as well as construction documentation, that's where the other tools like Tally LCA and Athena Impact Estimator might be a little bit more useful. These tools usually need a little bit more information about the specific geometries and specific material types in your assemblies and in your entire systems in the building. For Tally LCA, you do also need a Revit model. It's not a standalone tool. So you basically do have to have a little bit of a more developed design at that point to be able to do a life cycle assessment using Tally LCA. And then during the construction process, that's where our EC3 tool really excels. The EC3 tool relies on you to enter the material quantities It does now have some helping, some helper calculators to help you estimate amounts of materials even earlier in design, but it's primarily focused on the contractors and the construction stages because it has the most in-depth set of data sources. It uses environmental product declarations for the most specific types of embodied carbon data that you can get. So it really helps with product specifications and product selections at that point. There are also many other tools. So we're just focusing on our tools today because obviously those are the tools that we can demo and answer questions on. But there may be other tools out there that might actually fit your workflow. So for example, if you're using other building information modeling software, there may be other options for you. So I just want to make sure that we also highlight the fact that there's a lot of other helpful tools that can help you address the carbon footprint of your projects. Now, each of these tools usually have a very specific scope, so I do want to touch on that before we go further into the demos. The EC3 tool started with covering the production stages of the life cycle of a building, but it now also includes additional stages. So in its plan and compare buildings section, it can also help you assess the transportation and construction related impacts. But really the core of EC3 is, again, providing you with most specific data on the production impacts of materials from specific manufacturers, using specific supply chain scenarios, etc. Now, when we talk about the whole building LCA tools, those usually include the additional stages like use phase and end of life. Now, the main difference usually is that between the production or the A stages and anything beyond B, is that the A stages, even if you start with defaults initially, you can always actually track the amounts of materials and types of materials that are actually put into your building. Anything beyond the A stage, so the use phase, replacement aspects, and end of life disposal, you can usually run some scenario analyses, but all of those are really predictions of what is likely to happen, in 10, 20, 50 or 60 years time. So it can be a little bit high, there can be high uncertainty in assessing those types of impacts in the future. Now, this is one of my last intro slides. Again, which type of use is most useful to you depends on what the goal of your analyses are. There can be multiple different goals that you might be trying to achieve these days. So there are various policy aspects that you might be wanting to address. For example, the bike-lane policies focus on specific selection of materials and procurement of environmental product declaration for those materials. There's also some policies that focus on requiring whole building LCAs to be done, and then also showcasing the design decisions that you make that help you lower the impacts of your projects, in addition to the specific material choices. There are also typically internal commitments and benchmarking within firms that, from what I know, usually focus on carbon, but you can address other environmental impact categories with some of these tools as well. And then for the certifications like LEED, ILFI, BREEAM, again, those are very specific scope definitions in terms of the life cycle stages that you need to cover and the environmental impact categories that you need to cover. And some of these tools may be more applicable to specific type of certification than others. For example, the LEED whole building LCA credit requires to do a whole building LCA, so all life cycle stages, and also include other environmental impact categories, not just carbon. And so you have to consider that when you're using some of these various tools. In terms of what type of systems are usually included, mainly structure envelope interiors. You'll see that in Tally LCA, those are the main ones that you can capture. Some tools can also address furniture, MEP systems, and site elements, but most of the times those are not the focus of whole building LCAs today. Now that may be changing, and the EPIC tool actually, as an example, includes all of these systems in its analysis. I already touched on the various environmental impact categories. Again, there are multiple ones that whole building LCA tools can help you address. most often you will probably be focusing on the global warming potential, which is the embodied carbon footprint. So again, keep that in mind when you're selecting the scope of your study. And then lastly, you will probably be doing multiple analyses, multiple LCAs, or multiple comparisons throughout the design and construction of a project. And so when you're doing comparisons, it's very important to make sure that you do align the functional equivalence of your comparisons. You can make comparisons at various scales, so at the material level, assembly level, or full building level. You just always want to make sure that if you're making a comparison, you're making a functionally equivalent comparison. And with that, we'll move on into the first demo, and this one's going to be kind of brief, just to give you an idea of how you can first start to think about embodied carbon on a project, even when you don't have a detailed building model. I'm going to switch into my browser here. Give me a second. All right. And you can find this tool at epic.ehdd.com. So this is actually not our tool. This is developed by EHDD, an architecture firm out in San Francisco. But as I mentioned, this is a very useful early planning tool. When you log into the tool, you first need to create a project. So you go into the project section, create a new project. You do have to, agree to the use terms of the tool, just like you do in EC3 and Tally LCA. And then you can start defining the basic information about your project. For example, today we will be using, at least for Tally LCA, we will be using a sample project, which is the Autodesk Revit sample school design. So I'm just going to start creating the same project here in Epic. We'll say that we will finish this year. I'll put in my location in Oakland, California. And then we'll just keep the baseline structural system at the default. We will select the K through 12 school here and number of above ground floors. If we keep on going with that earlier massing design that I showed, that has 3 floors. And then each of the floors, so the total floor area of that building is about 5,000 meters squared. Now, Epic does require you to enter stuff in square feet or in imperial units. And so each of the floor areas is going to be about 18,000 square feet, I believe. It's not super important. We're not trying to compare the results of each of these analyses, but I'm just walking you through the steps here. Now, once we fill out all of the basic information, we save the base case here. And you immediately get an idea of what the typical impacts of a similar sized K through 12 school might be in that location. Now, Epic also shows you operational carbon, so you get 6,000 tons of CO2 equivalent here. But in the red section, you do get the embodied carbon. So embodied carbon is something that you could then start correlating or comparing to something like the Tally LCA tool results or EC3 results. Now, this is an initial idea of what the typical school of this size in this location is. Now, what Epic is really useful for is also showing you or helping you analyze various scenarios early in the planning phase. So for example, we can assess if we were to actually reuse part of an existing building. Let's say we reused 50% of the structure. You can quickly assess what the potential reductions in embodied carbon could be because of that scenario. Now, this will take a few seconds, but I dragged over the structure reuse to 46%. And you will see in a second that these results here will adjust. And they show you that there's a 680 tons of CO2 equivalent potential reduction in the embodied carbon footprint of the building. Now, I should probably talk a little bit about what this diagram shows you. So it does show you the embodied and operational carbon accumulating over time. So you can see at year 2024, you have mostly embodied carbon within the building itself, very little operational carbon. And then as you move to the right side, up to year 2050 and beyond, you can see that the operational and embodied carbon ratios change a little bit. But you do also see that there are some maintenance and replacement aspects, even in the embodied carbon section, where you still see that bar going up over time. Now you can also look at this a different way. So you can look at the embodied carbon budget here, and that shows you the breakdown of the embodied carbon by the different systems that I mentioned on one of the earlier slides. And so once you're trying to actually use this in tandem with some of the other tools like Tally LCA and EC3, again, it's just very important to make sure that you are comparing the same types of systems and the same type of scope in terms of life cycle stages. Now you will notice that there's many other things that you can also adjust in the scenario analyses, including the EUI target. So if you wanted to focus on reducing the operational aspects, you can also assess that using this tool. But ultimately, once you make some selections here, you can run a couple of different scenarios and then compare the final results of the various scenarios that you've defined. I'm not sure if I can actually do that here. Yes, I can. So now you can see that I have my baseline, CLF Hub School, which was this line at the top, but I also have that first scenario with the 46% reuse of the structural systems. And again, you can modify many different things and see the basic outlook of your embodied carbon footprint of a project very early on without actually having any 3D models or anything like that. So that's really all there is to it, to the Epic tool. I did want to make sure that we do cover that very early stage as well. Are there any questions so far about the Epic tool? Now that I'm 100% sure that I'll be able to answer all of them, but if there are any high-level questions about how you can start with this tool, you can share some of those questions in the chat. And in the meantime, I will switch my screen to start the Tally LCA demo. All right, I don't see any questions in the chat, so we'll just keep on going. So now we'll move on into the Tally LCA walkthrough, and I'll go through the basics of using Tally LCA, but also go through some of the a little bit more advanced things like how to compare design options, how to transfer material information between models, etc. So let's start with just basic understanding of where to find the tool. First of all, you probably noticed we are inside of the Revit interface, and we do have this sample building project that we also shared with you before the session. Now you can find Tally LCA here in the add-ins section and simply click on the Tally LCA plugin icon. Now you do have to install the plugin ahead of time, so I hope that anyone that wanted to follow along today has actually done that before the session. If not, it usually doesn't take too long anyway, so you can probably do it right now as well. Now, the first step in Tally LCA is defining the object of the study. So basically, we'll start with the scope definitions of what you're trying to do. There are a couple of different study types that you can do in Tally LCA. The most common one that people probably use is the full building study. That just means that you take your currently modeled building, assign materials to it, and run the life cycle assessment analysis on that building. There's also design option comparison, which we will go through later on, but you can select various design options in your Revit model and then do a side-by-side comparisons of those design options. And again, those can be assembly comparisons. I have seen people actually design entire buildings as design options to be able to do comparative analyses directly inside of Tally LCA. And then there's also the define template file, which means that you can assign materials to any of your standard assemblies and standard Revit materials that you may use within your firm without actually having any 3D geometry placed into the file itself. So we'll go over that as well. Let's start with the full building study. So here you will see the list of Revit categories that Tally LCA can cover. Again, this mostly focuses on structure and envelope, as well as some of the interior aspects. It does not, for example, cover furniture or MEP systems. So that's one thing to note. Now, on the right side, you can also select scope based on your Revit work sets, and you can also include or exclude specific elements depending on which phases they are actually assigned to in the Revit model. This is not the greatest example here, but I've been on projects that had multiple phases, for example, listed here. And so we could do life cycle assessments on specific phases of the design for that particular building. In some cases, I've also seen historical models from, let's say the 90s or 2000s, etc., and basically what the building looked like in previous stages. Now, once you select all of the things that you want to keep within your analysis, you can click on the Apply button. And while this is loading, so this is basically collecting all of the dimensional information about the individual elements and families that are placed in the model down below. So at this point, the tool has collected all of the dimensional information and it lists all of your families here. You can reveal each of the families and also see the individual layers within each family or subcomponents of each family. Just by revealing those carets here. You can also reveal the whole list just by clicking on the family or the material section in the header. And you probably already noticed there are different colors and icons that help you quickly identify, either if you've defined things already, if there are errors in the model, or if there are missing materials. All of those icons and colors are described here in the legend. What usually you will start with is everything being this light gray. That means that no material have been actually assigned to the Revit model. And by what I mean by that is we obviously see the Revit material here, but what you need to do next is assign the environmental impacts from the Tally material library to those Revit materials and elements. So that's what we'll go through in the next few steps. Yeah, so let's go on to the next step then, and that is assigning material types. So let's say we just looked at this for ceiling. We see that there's gypsum type X Revit material listed here, but there is no environmental impact information actually assigned to this layer. So we can right click that, click on edit definition, and then we need to search through the Tally material library for gypsum wallboard. So I can just start typing and it will start helping me find that wallboard gypsum material type in the Tally library. Once I find it, I can click on it and click on apply, or I can right click it and click apply as well. Now the next step is going to be giving Tally LCA some additional information about exactly what type of gypsum board this might be. And also helping it define the takeoff method that it should be using to estimate the material quantities. And there may be some additional questions that it may ask you to get a realistic material quantity takeoff estimate. So in our case, this was actually a gypsum wallboard type X. So we'll select that material type from the library. And now we're defining a takeoff method. There usually are multiple ways that you can do a material takeoff. You can either take the full modeled volume of an element, or in this case, I actually have an option of just taking the wall area or the ceiling area, defining the wallboard thickness from a list of real thicknesses that you can actually buy on the market, And then it uses that information to estimate the total amount of the material in mass and in volume. Now, again, the benefit of using the takeoff method by area and using some of the drop-down pre-selected lists is that you don't necessarily need to have everything modeled fully to its realistic dimensions. So you can just do a basic representation of an area of wall system with, you can even include unrealistic thicknesses of the individual layers within your Revit model itself. But you can select the takeoff method in Tally LCA and then select from real thicknesses of products that are on the market. The benefit of using the takeoff method by volume is that if you change the dimensions or the thicknesses of the Revit layer itself, then the next time you run the LCA analysis, you don't actually have to touch this part at all. It will understand that the thickness of the modeled layer has changed based on the Revit information. So again, there are pros and cons to using some of these takeoff methods. It just depends on exactly what material you're talking about and probably which phase of design you're in. You will also notice that there are additional accessory materials that are not necessarily modeled in Revit, but you have an option to add. So for example, paint finishes. We can add a paint to this wall, to the ceiling layer. And also, because this is a wallboard, gypsum wallboard, sometimes they can also have foil facing. And so if that's relevant here, you can select it. If it's not, just click on the None button, and you will see that this light turns green, and we can move on to the next step. Now, at this point, we can click on the Save button, and the tool will give you an overview of what we just did. So we just defined that we had wallboard gypsum fire-resistant type X, modeled by volume, and that amounts to about 1,000 kilograms. Well, actually, that's the density that Tally LCA has for gypsum wallboards is 1,000 kilograms per meter cubed. It also has 181 kilograms of paint that was estimated based on some of the default values of how much paint is applied to a particular layer. At this point, you can click on Apply, but also I do want to point out that on the left side, the tool will identify which other families are using the same Revit material. And it will ask you, do you want to assign the same material definitions here on the right to all of the families in the list on the left? And if I did want to do that, I would check this box, click on Apply, and you will see that that same material definition automatically got applied to gypsum type X down in the plain ceiling family. So you can really speed up the process of assigning materials by going through and checking the additional families where that material assignment is relevant. We'll go through one more example here. So for example, the metal stud layer. Actually, let's go through some of the wall systems here. Let's go to the walls. Let's go into this interior wall with the gypsum type X. We actually quickly define that one. So gypsum again. Apply, we'll do type X. We'll just rely on the geometry that was modeled. So takeoff method by volume. We'll again do interior finish, foil facing, none, and then save that material assignment. You also see that it's in the exterior insulation and masonry wall. So we'll include it there and click on Apply. Now you also notice there are two other layers of gypsum wallboard in the same family here. But you don't have to go through the same process again unless those wall families or those gypsum wallboards are actually different. If they are the same, you can right-click that gypsum type X layer and say copy definition from, select the same wall family, and it will automatically be assigned as well. We'll do that same process for the last one. And now you see we have all of the gypsum type X wallboards applied. Now let's do one more assignment of materials just to see what type of different drop-down selections you might have. Let's look at the metal stud layer here in the wall system. Edit definition. Go look for studs. Seal stud metal framing we'll do without insulation, so just the framing in this case. Apply. Now here you will actually see multiple different steel types. Usually when you're not sure which steel type or steel data source you should use, the first one is usually the most generic one. So you could do that. And then we go into the takeoff method. In this case, for the studs, you actually see a new takeoff method, and that's by spacing. And that one's just going to be the most relevant for anything that works kind of like studs, where you have individual profiles of materials spaced at a certain distance throughout the entire assembly. So in our case, we go and select a specific stud profile. Let's say this is a 3.5-inch stud with 20 gauge steel. And we have one-way spacing with perimeter members. That's 16 inches on center. At 16 inches, click save. And you will see that we have 11,000 kilograms of cold form structural steel in that 2,000 meters squared of a wall area that uses this interior partition wall system. If we did the takeoff method by volume here, we would probably have something like 1 million kilograms of cold form structural steel. So this is why some of the calculators that Tally LCA has built in can be very useful. Now, let's say that we walk through the entire project and fill out all these materials. I'm going to cheat a little bit, and I'm going to switch over to my project that actually has that done. I'm going to switch over here. By the way, one of the projects that you have access to says complete, and that is the project that has all of the Tally material assignments filled out as well. So it's going to look very similar to the one that I'm opening right now. Now we'll go into full building study again. In this case, in my selection of scope, you actually can also notice that I am including a linked structural model. So we didn't see that in the last example. But in this case, there is a separate file with all the structural systems. The structural systems have been defined on their own, but now I can actually include them in the overall analysis of the project. So I'll select sample schools STR as well, click on apply. And once it collects all of the dimensional updates, you'll see all of the Revit categories again. You see that in my case, most of them are green. That means most of them are fully defined. There's one wall or two wall assemblies that have not been fully defined with Tally materials, but that's okay. You can still run analysis without those. And then also you see the linked structural model has all of the information here as well. You can also see all of the details of the materials that were assigned to that model. So what can we do now? Well, we've been assigning materials. The next step is actually running an analysis and using it to understand the impact of our project. So we'll go into the save report section. Here you need to fill out some main, some main information about your project. The most important parts here are the gross building area and the expected building life, because those are actually used in various calculations for the analysis. For example, the tool will give you the overall impacts of your project in the absolute terms, but it will also give you the results on a per meter squared basis. And that's very useful for being able to compare to other projects within your portfolio or even other firms' projects if there are benchmarks, etc. Now, the goal and scope of assessment section is a free-form field. It is always a good idea to describe in detail what was the goal of the assessment, what was the scope of the systems that were included. Did you take a simplified approach to assigning all of the materials, or are they reflective of the actual actual specified and procured materials later on in design? So it's always a good idea to fill this out as much as possible. It does show up in the final report that other people can then see and understand. You can also edit transportation distances. We do have some default values for all of the various material types. And this is most likely all you can do in, during the design phases. Once you get later in the design phase or in the construction stage, you can start refining what the specific modes of transport and distances are. And Katie will go through the transportation stages in the EC3 tool as well. There's a little bit more flexibility in that tool in how you can define multiple legs of transportation modes as well. But with that, you can keep everything at defaults. You have an option to include or exclude biogenic carbon, which may be a little bit of an advanced topic, but depending on if you have bio-based materials like wood products or not, there is some discussion of being able to account for the carbon that is being stored in those types of products based on the sequestration of carbon by trees when they grow. So you can do an assessment by including some of those sequestered biogenic carbon flows, or you can exclude them and just focus on the fossil-based emissions. You can also include construction impacts and operational energy impacts. You just need to have the overall fuel and energy quantities and then link them to the specific sources of those fuels and electricity. Now, we're going to focus on just looking at the material impact, since that's what tele-LCA is most useful for in this example. So at this point, you can click on Save. You will need to specify, you will just say what the name of your project is, save it. And then it does take a couple of seconds to generate all of the reports. The first report that you will see is this PDF report. And then in the background, there's also an Excel report that is being generated right now. So we'll come back to the Excel report in a second. Now let's take a look at the PDF report. So on page 3 is where your results start. You will see that at the top of the page, you have the basic information about your project. You would have the goal and scope of assessment description here if you filled it out all the way. And then the first set of results is down here at the bottom of page 3. The top table is the absolute impact values for the project. So you can see 3 million kilograms of CO2 equivalent in the product stage. In the bottom table, you see the per area results for the project. So you can see 625 kilograms of CO2 equivalent per meter squared. Now, this is also your first you are able to gauge the quality of your assessment and the quality of your model by looking at this number sort of as a first indicator. Usually the carbon footprint of new construction projects is somewhere between 200 and 1,000. If it's below that, you're probably not including all of the elements, or you have a lot of reused elements. If you're above 1,000, it can be likely that you modeled some of the things in Revit incorrectly or slightly in a way that's not compatible with the way tele-LCA estimates things. Also, if you, for example, did an analysis with the metal stud defined by volume or taken off by volume, again, that could, hugely overestimate the carbon footprint of your project as well. So this would be a first indicator to look for. Now you can see that we are including multiple life cycle stages here, as I mentioned earlier, and also multiple environmental impact categories. And this is something that, for example, LEED would be asking you for, these specific environmental impact category types. Now let's go into the subsequent pages. So here you will have a number of different bar charts and pie charts. Now, all of these bar charts and pie charts are showing the same exact results, just slightly different ways. The first one shows you, again, the impacts by various life cycle stages. You can see that in this project, most of the global warming potential impacts, for example, are in the production stages. So 81% are in the production stages. There's some in the transportation, but very small. There's some replacements of interior materials, and then some end-of-life impacts at the end. But overall, you can see production stages are the biggest piece of the pie. On the right side, you actually get it broken out by CSI divisions as well. So this is a little bit more helpful now because you can start narrowing down into the material types or assembly types that actually contribute the most. And then you can go back into your design and consider a couple of different alternatives. Let's take a look at a couple other charts here. Let's take a look at this one, for example. You can again see which Revit categories are contributing the most to the overall impacts of the project. It looks like the floor systems here contribute 51% of the global warming potential. Now, this makes sense. There's usually a lot of concrete in those floors. I would also caution that sometimes I see duplication of floor systems specifically when you have architectural and structural models. So sometimes, you do need to look out for double counting of some of the elements on a building. Anyway, first step that you can do during the analysis is just look at these diagrams, see where the biggest contributors are from the environmental impact perspective, and then go back into your model and try and better understand where those impacts are coming from and consider some alternative design or material options. Now I will try and answer one live question. Is it possible to preview the results and all charts on Tally LCA without needing to download the PDF report? Right now, no. Right now, you always need to generate the PDF report first. So there's no live showing of the results within the plugin itself. There's another quick question. What is the best method to take off the steel amount by steel profile or volume? Because there was a notable difference between these two methods in my project. Great question. It comes down to how your team actually models the steel profiles. If you are confident that you are actually modeling the profiles to their true dimensions, then doing the takeoffs by volume makes complete sense. But I have seen a lot of the times people simplify the individual elements and how they're modeled in Revit. And in that case, it's better to go and use the drop-down lists of steel sections specifically. So it again, it depends on exactly how your team is approaching the modeling of the individual families and elements. Can you download the reports to Excel format? Yes, that's actually a great segue. So you will notice that in some cases, if we're, for example, looking at this chart here, and we try and understand which material types contribute the most, let's say in the wall systems, you do see that we have various shades of red. But if I scroll down, scroll up to the top, it's very hard to actually understand which wall families are which. So in that case, I wouldn't really bother with looking at this diagram. I would simply go to the Excel report. And that one is downloaded automatically once you hit the save button inside of Tally LCA. And this is what it looks like. It has the tabs structured exactly the same way as the PDF report. So you'll notice that if we were up here, it said results per Revit category itemized by family. So I can go into the Excel spreadsheet and go into Revit category and family. So this is the tab. And now I can see the ceilings and I can see the individual families and all of their environmental impacts across the horizontal. Now, let's say we wanted to focus on global warming potential. That's in this column. You can see that the 2 by 2 foot ceiling grid is the largest impact here. So you don't have to rely on trying to decipher the PDF bar charts. You can simply go into this Excel spreadsheet and start, looking at specific things and see the actual numbers. You can also then use these numbers to generate your own comparisons and your own charts if you have specific graphic standards within your firm. You can also go, so this is basically a pivot table. you can modify the pivot table and reveal additional information about each of these families and really start diving into the nitty-gritty of the individual results of your project. Now, I will note here, sometimes people actually have trouble getting the formatted Excel report like this. Sometimes they end up with an unformatted CSV file. In most of those cases, there can be two reasons for it. Either you have the same exact Excel file already open with the same name, or what's more common is that you do need to go and repair your Microsoft Excel or Microsoft 365 installation. Sometimes there is some corruption in the installation of those tools, and if TallyLCA cannot access them, it might not give you the fully formatted Excel report. So just look out for that. Now, a couple last things on the PDF report here. We'll go to the next few pages. First of all, you do get the full calculation methodology that TallyLCA is using. So this is all the same for all projects. This is not specific to your project, but it can be a good idea to read through it at least once if you're brand new to life cycle assessment of buildings. It also does go into the various life cycle stages, what they mean, which ones are included in TallyLCA, gives you more information about the environmental impact categories. But once you get through the calculation methodology, it also gives you the specific underlying methodology for the material data points that you're using on your project specifically. So we'll go into this page, LCI data continued. I believe this is where the individual material information starts. Yes, right here. So LCA data product A1 to A3, that's the section where the information starts. You will see that this is structured by the name of the tally material that you've assigned to various parts of the model. And it gives you the overall mass estimate of that material. It also gives you a list of the families where that material is present and the amount of the material in those families. And here it gives you the lifetime of that element. So for example, here it says 50 years. That means there is one replacement expected over the 60-year lifetime of a building, one replacement of the ceiling system that's accounted for during the maintenance and replacement phase. It also gives you additional things like description, life cycle inventory. It's kind of basic in this case, but in some of the material cases, it can be a little bit more substantial. And it does give you the default transportation distance that's accounted for, as well as the end of life assumptions for the disposal of the material. Now, all of these again start as default. Now, this report can get very long because obviously it's covering all of the materials that you've selected on your project. I will know that this is another potentially a good way of quality assuring your model is taking a look at the back of this report and making sure that all of these masses actually look, first of all, relatively similar. There's no outlier in the list. There are no zeros unless you know that you've actually reused some of these materials. And otherwise, you can actually use this to identify potential issues with your material assignments and with your model. So let's see if there are any more questions. These charts supply a lot of data. How do you benchmark or put a relative value on the results so you know how well you've done on a project design? Great question. So at a whole building level, it's a little bit tricky because there is no centralized benchmarking database, at least not at a scope that we would need it, to be able to just say, okay, I'm going to compare the set of my results here to some other arbitrary project or some other project that is relatively similar to mine. So what people usually do is they create a baseline assessment of their own project. Then they go and analyze, where could we make some improvements in the design options? Where could we make some material swaps? And generate a whole set of results for those alternative scenarios. then you can use either Excel or you can use the Tally LCA design option comparisons to see how much it helps you to move up or down within each of the material categories, each of the impact categories. I will show you one example of a design option comparison, but again, you can do this at various levels. So let's talk a little bit about design option comparisons. Let's go back into Tally LCA. Let's go back into the define scope section and go into design option comparison. Now, in my case, in this particular project, there's this option set 1, which is the butterfly roof and the flat roof. And if I select it, you will see both of those design options listed, butterfly roof, flat roof, and then the individual, again, Revit categories and materials that are related to each of these options. Now, what do these options actually represent? Let's take a look at it. So I'm gonna put this aside, and I'm going to try and select this. Okay, I can do it from here. So basically, in my model, to show you directly in Revit here, I have this atrium right here. And if you are familiar with Revit design options down at the bottom, you can flip between the butterfly roof, which is the main option, and the flat roof, which is my other alternative option. Now I've fully designed this right in 3D inside of Revit as a design option. And this is not necessarily a full tutorial on how to use Revit design options, but this is where you access them and this is where you can add additional ones. You essentially assign the entire assemblies with specific Revit materials, specific family types, and then they are saved in your model as alternative design options. So we have the flat roof, butterfly roof. You can see that we've assigned all of the materials exactly the same way as we did before for the full building analysis. And now if I save a report to test design options, now you will get a report of just those atriums, but you will get them actually listed side by side so you can see what the differences in the impacts are. So again, the report looks very similar, except now instead of a single set of results, you actually see multiple results listed next to each other. Now let's go into some of these other charts where we can actually see the contributions of individual material types. Let's do this one on the left. So you can see that we have design options, butterfly roof, flat roof. Those are identified as 1 and 2 here up in the bar chart. And then you still have the individual master format divisions and individual tally materials that are listed here. You can see that from a global warming potential perspective, the butterfly roof actually is a better option here. It looks like mainly because we avoided this whole yellow part, and that is the lightweight concrete for some reason. So it seems like the structure in one of the atrium's roof systems is using a different material type. So you can start using this design option comparison to maybe evaluate your standard wall assemblies. You can, as I mentioned, you can even assign entire buildings as various design options and then do comparison here. And just like we had before, we also have a full Excel report with all the values provided to you in an Excel format as well. That one is still loading, but here it is. You will see we have butterfly roof and then the flat roof option down below. So,
Václav, on that Excel workbook, there was a question about editability that you just had open with the pivot tables.
yes, I believe so. I think it's actually locked by default, or it used to be locked. It shouldn't be locked anymore. You should be able to edit that Excel spreadsheet all you want, and that includes revealing some of the pivot table features. So it is fully accessible and editable by you. All right, I think let's take a look at one last thing maybe here, and that is defining the template materials. So, oh, actually, let me mention one more thing. On the design option comparison side of things, I wanted to point out the kaleidoscope tool by Payet. This is a prime example of what you can do with the design option comparison. So Pyatt, an architecture firm out here I believe they are here in the Bay Area as well. They've used LCA to assess a number of their various standard envelopes, floorings, and ceiling assemblies. And they actually make this freely available. So you can go and use the tool and see what the impacts of various assemblies are: masonry veneer, curtain wall, rain screen, etc. And it gives you a little bit more information about how they actually structured the individual assemblies as well. But this is exactly what you could use TeleLCA for and the design option comparison for, is have a set of pre-designed assemblies and then start comparing them one to another. Okay, let's come back to TeleLCA and go over the last section of this demo. So I mentioned that you can go and define templates. So I'm going to open up the plugin again. We'll go into the object of the study and we'll go into define template file. Now, if this is the exact same file that we looked at earlier, where all of the lights actually turned green whenever we move to the next step, right? So you'll see that there's a difference right here. You also are not actually selecting the scope of the analysis, like the work sets, phases where elements were created, etc. You're simply just accessing all of the families that are loaded in your file, no matter if they're placed or on any work set, etc. So at this point, you can go and apply. Now this might take a little bit longer. Okay. Now you can see that previously all of these were green, but not anymore. Why is that? Well, because there are many other wall families that I can actually go and select from here on the left side. For example, in the architecture tab, go into the wall sections. And if I wanted to place some of these other walls that are not actually placed yet anywhere in my model, I could simply go and select from one of these and start modeling, right? Now, if I placed a wall that I haven't really assigned telematerials to before, then I would have to go into the full building analysis after I place any new family and assign those materials again. Now, what you can do with the defining template files is that you can actually go and assign materials to all of your families, no matter if they're placed in any project. This can be very useful if you have a standard Revit file within your firm that you usually start with, and you want to make sure that all of your designers have access or can run analyses immediately after they start placing things without having to actually go and assign materials themselves. So you can go and assign all of the materials here, and then as soon as somebody starts placing elements into your 3D space, that will automatically be all included in the next analysis that you run. There's one more helpful feature for speeding up the process across your firm. If you do have access to the premium license of TeleLCA. If you do have that premium access, let's take a look at my model where I didn't have anything assigned again. You will see how we can actually transfer information from one file to another. Just need to find that project. I believe it was this one. Yeah. All right, so we'll open up TeleLCA again. We'll do full building study. In this case, we're trying to assess this blank project. We'll select all of the scope, click on apply. And now we're going to be in the place where we see all of the individual elements and their layers. Now, let's say we have these wall systems that have not been defined. So this typical partition wall has this wood stud layer. Now I could go and define this material again, from scratch, but there's another thing I could do. I can go into manage definitions and I can transfer material definitions from another file. So if you remember, we have that other file that was fully completed, also loaded in the same Revit instance. So I can go into the source Revit model drop-down menu and select, I believe this is the R21 ARC model that I had opened. Now this model now shows me the list of all of the calculations or the materials that have been assigned on that project. And for example, we were talking about the wood studs, which are all the way down here. Can go and take a closer look at the wood framing formula. And we had the domestic softwood material assigned there. If I hover over it, you can also see the additional definition information, like the size of the wood studs, etc., and the spacing. Now, if I wanted to transfer this and actually assign it to the blank model, if I'm using the same Revit material naming across both of those models, I can actually look for related families automatically. So right-click this, you can see check matching material families, matching materials in any families, and there's at least one that it can find. We'll click that, and it will automatically select it on the right side. Now, if you weren't using the same naming convention in both files, then you would have to go and find it on the right side manually and select it manually to be able to transfer the material information. But if you do use the same naming, this can be a little bit faster. Now, once the wood stud layer in the blank model is selected here, you can click on the apply button, confirm that we want to transfer the material information. And at this point, the wood framing has moved from the undefined section to its own defined section. And we can see the formula listed here. Now, once I'm done with this, I can simply close that window, and you will see that this all of a sudden turned green, and we have all of those same material definitions here on the right side. So again, this is another way of speeding up your whole process of assigning materials in your projects. So I'll wrap it up here. We still have the whole EC3 walkthrough and tips and tricks ahead of us. But let me see if there are any more questions on Tele LCA specifically. And Ben or Katie, feel free to just point out any questions that you saw.
Yeah, there was actually
through.
one on Epic up above, and then maybe one on Tally that might not have been addressed. So from Sophie, there was one on Epic, and then Eric Fleet after that.
Okay. Is the embodied carbon over time shown in Epic total embodied carbon divided by the lifespan of the building? So it shows you, let's come here. So yeah, so this is the cumulative amount of carbon over time. So the way that it's showing you, right, the embodied carbon emissions here, 3910, that's the total over time, including any of the replacements, etc., over the period of the lifetime of the building, which Epic actually, I think, currently is assuming 50 years. Normally in whole building LCA tools, the lifetime is typically 60 years. I believe Epic actually uses a 50-year lifetime, but I know they were making some updates to make it more flexible recently. I think if you go into the base case, go into refine scope, right, it's actually 30 years here. So they've changed it slightly. It used to be 50. Now you have an option between 30 and 60 years. And you can change that analysis period. But otherwise, the answer is they are the totals over the lifetime.
And there's two more right below that question, Václav.
Okay, are tally definitions saved when a new local model is created from a central model in Revit? In other words, are the definitions tied to the central model or the local model? Great question. So everything in Tally LCA is being saved directly to the model that you're working in. So it's very important that you keep on saving your model and that you're checking out the central model when you're trying to assign materials. Because when you save, it works just like any other modifications to your model. TallyLC actually appends information in extensible storage. So it doesn't modify any, dimensional aspects of your model. It doesn't change any of the Revit material assignments. It just appends information to them. And so you would want to save and sync the model back to central. If you do that, all of that information is being sent back to the central model. And it doesn't matter if it's you or somebody else that then later on opens that central model on their local machine, they will still see the assignments that you've last attached to the model itself. Another question, is Building Transparency working to expand their tools to be more inclusive of more general infrastructure projects? I would love to use something like this for my work in the power industry. So I think the response is for Tally LCA specifically, because it's just a Revit-based tool. It's not as easy to do, right? It's to adjust the tool to help with infrastructure projects and other projects. The other part of the answer is though that with EC3, which is its standalone tool, we are actually looking into adding, for example, instead of a building planner, an infrastructure planner. And there's also some plans or, we're aiming to also potentially have other integrations with more infrastructure focused modeling tool that are not just Revit. So we are, intending to make that more widely available beyond just the building industry with the EC3 tool. We still have yet to see what exactly happens with LCA in terms of broadening the scope.
And then
Is there
Václav,
anything else, or
there's one
are
that
we
got
good?
there's one that got thumbed up a couple times related to particular material EPDs, maybe just to comment on, and some of that maybe you can tie into Katie's section, but we can come back to questions. But if you want to address that one.
Yeah, so for specific EPDs, there are some already in the tool, but the tool was actually initially developed with generic background data that was all harmonized in the background. If you know a little bit about the intricacies of lifecycle assessments, there are multiple background LCA databases that can have slightly different scopes within themselves. And so it's usually best to stick to a single type of data source when you're trying to make comparisons. And for that reason, Tally LCA historically has kind of steered away from EPDs. Now we do get a lot more of these requests. We will actually be updating some of the industry-wide EPD data points in Tally LCA. And we are also, looking into potentially adding some EPD data for materials that we currently have just no data for at all. But really, ultimately, the place where you will be able to compare one EPD to another is going to be inside of EC3, at least in the near term. The reason is because EC3 focuses just on the global warming potential category, and it does have some ways of actually also comparing the specificity of the various EPD results. It's a different and much simpler topic or slightly simpler topic of aligning results from EPDs for the global warming potential category versus all of the environmental impact categories that are listed. There's generally much more alignment in the methodology behind the global warming potential estimates. There's all kinds of intricacies and challenges in making sure that the other impact categories, first of all, use the same equivalency units, and also that the underlying data sets actually have the same scope in collecting all of the emissions associated and contributing to the other environmental impact categories. If you do have specific EPDs that you want us to include in Tally LCA, please reach out to me. I'll share my email address. We are collecting a list of requested materials as well as some specific EPD data points that people are requesting. And we'll kind of accommodate those on a case-by-case basis. Katie will get into EC3 in a minute. If you are working inside of EC3, you already have access to a whole number of environmental product declarations. And you can also just take your PDF that you have in hand and upload it into the tool. And it will also get added into EC3 itself. And Katie will probably touch a little bit more on that. So I'll hand it over here.
Thanks, Václav. And actually, Javklon, sorry if I'm mispronouncing that, but he had a question about exporting Tally to EC3, which you can do when you update the EC3 building project with an EPD. That does not change the Tally LCA project, so it doesn't go back and forth in that way. Is that correct?
Yeah, that's right. And that's one of the small differences between our Tally Climate Action Tool, Tally CAD, as I mentioned earlier, versus Tally LCA. Tally LCA, like you mentioned, is a one-way road. You can't really go back and forth. But if you are only focusing on carbon footprint, then Tally CAD might be a better option because then you have a two-way communication between the Revit model and your embodied carbon estimates, and you can make adjustments over time.
Great. Well, thank you, Václav. That was great. I just learned a lot about Tally LCA that even I didn't know. So thank you. Today I'm going to be talking about EC3. I'm just going to explain just some of the core functionality of the tool, and we'll do some hands-on exercises so you can get comfortable with finding EPDs and adding material quantities and building new projects. I also want to highlight some of the new policy compliance features that we've recently implemented. So I'm just going to jump in here. I know this might be daunting as a first slide. I just wanted you to see it and visualize it. This is the way we help you visualize the range of results of specific searches of material EPDs. And I'll go into more detail into this here in a couple of slides. So first and foremost, embodied EC3 is the Embodied Carbon and Construction Calculator, and it serves two primary functions. One, it is a public, free, open access database of product-specific EPDs. We have both Type 3 third-party verified EPDs and industry-wide EPDs in the database. So if you're just simply searching for an EPD, you can do that. It is also a building project planner, as you might hear us call it. This is the plan and compare buildings feature where you can build embodied carbon estimates by entering material quantities and selecting EPDs or assigning collections, as we call it. So you'll hear me use some of these sort of EC3 terms, and I'll explain what they mean as I go through the demo. And just to reiterate what Václav presented earlier, the scope of EC3 is limited to global warming potential. That's the only environmental impact indicator that it quantifies currently, and it is currently focused on the upfront product and construction stages. So you might hear those referred to as A1 through A5. Just a note, we are working on adding some of the B and C stages, so the scope of EC3 will be expanding in the future. Okay, this is the find and compare materials feature. Just as I mentioned before, you can search for EPDs. You can view statistics for filtered EPD results, and I'll show you a demo of that here in just a moment. But I want to walk you through, before we get into the tool, how to interpret this box plot and whisker diagram. So when you conduct any search, such as I want to know what are all of the product-specific EPDs in the state of Washington for ready-mix concrete for 4,000 PSI mixes. When you enter those search terms or that criteria, one of the results will be this box plot and whisker diagram. So I want to walk you through how to interpret this. First, at the top, you'll notice the measurement units. So because we're talking about GWP, that is kilograms of carbon dioxide equivalent. And then per cubic meter, depending on the units of measure that you have set in your settings in EC3, You can either view these in metric or imperial. And this will also be determined by the product category rule, the declared unit in the PCR for this specific material category. So the way I interpret this is based on my search, the maximum GWP or the highest GWP is 819 kilograms of carbon dioxide equivalent per cubic meter. That is the highest embodied carbon of any EPD found based on my search terms. The lowest or the minimum here is 296. We consider those outliers. But between this green box here, this green shaded box, the top bar of the green box is what we call the conservative value. That means that 80% of EPDs have an embodied carbon lower than this number. In this case, it's 760 kilograms of carbon dioxide equivalent. The achievable, we define as the 20th percentile. So 20% of EPDs have a value at or below 410. We also have the CLF baseline values built into the back end of EC3, and that will show up if there is a relevant CLF baseline value for this material category, that will show up as a purple line on the box plot and whisker chart. So I know somebody asked a question earlier about points of reference, or, how do we know how we're doing against some sort of a baseline or benchmark? The CLF baseline value serves that purpose. Okay, and just to briefly revisit this chart before, how are these box plot and whisker charts developed? Well, they're developed by basically aggregating all of the product-specific EPDs that meet our search terms, as well as the industry-wide EPDs. And as you can see here, each product-specific EPD basically counts as one data point towards the box plot, whereas the industry-wide EPD counts for multiple. If you're interested in learning more about our methodology that we've built into EC3, I will point out some useful resources within the tool that you can read more about. Okay, so with that, we're going to jump over to EC3. And I'm going to, if you do not yet have an account, you can go to buildingtransparency.org and click register free. If you have a work employer given email, make sure you use that. If you use a private email account, such as a Gmail account, you will be granted sort of a slightly lower permissions tier than an employer given email address would get, which is a professional access. So the demo that I'm going to be giving today is with professional access. So you'll just fill out all that information, create login, and you'll get an email to prompt you to confirm your registration. Once you've done that, you can log in to the tool by clicking sign in here, entering your credentials, and I've already done that. I'm going to go here. So I am logged in, and this is the main dashboard of EC3. Just walk you through a couple of things we see here on the home page. The first thing you'll probably notice is this heat map. This is a way to visualize basically where we have EPD data from across the globe. It's important to note that these are based on manufacturing locations from the EPDs. So the darker shades of blue mean we have more EPDs from those geographies, and you can toggle between concretes and non-concretes. You can zoom in and view a map of the US and see this data broken out by county. Again, toggling between concretes and non-concretes. And then Europe, and then a bar chart here. So as you can see here, we have 127,000 ready-mixed concrete EPDs. As you can probably notice just by looking at this bar chart, that is a drastically higher EPD count than any of the other material categories in the system. That is really just based on the nature of ready-mixed concrete. So each plant and each unique mix design at a plant will have a unique EPD. Because of the regional nature of ready-mixed concrete, as you can imagine, that number of unique mix designs globally can really add up quickly. Okay, so I'm going to start by just demoing from the top here, find and compare materials. This is where if you just wanted to search for an EPD, you could do that. As you can see here, we've got what we call a category tree of all of the material categories we have in EC3. You can expand each of these parent categories and see the subcategories beneath them. Here's ready mix concrete. Under masonry, we have CMU and brick. Steel, there are a number of subcategories, and then structural steel, hot rolled sections, hollow sections, and plate. So I encourage you to just kind of play around and browse around and get familiar with the material categories that we have in the tool. I have a background in concrete, so I like to demonstrate concrete when I'm using EC3, but if there are any other specific requests for other material categories, just let me know. So let's say we want to see how many EPDs there are for 4,000 PSI mix in the state of Washington. Let's use that example I mentioned before. So as you can see here, when you open any material category, there are going to be performance filters that we've built out that are specific to that material. So in the case of ready mix concrete, compressive strength is one of the key performance specs that I encourage users of EC3 to narrow their search results, specifically by compressive strength and geography. You can play around with some of these other filters. Just a word of caution that some of them are not accurately tagged to every EPD in the system, really because the PCR doesn't require ready mix EPDs to report all of this information. So we've tagged the EPDs with some of this information, such as slump, for example, to the best of our ability. But if you're filling out all of these filters and you're finding that you're not getting a lot of search results, just try to step back and look for compressive strength and geography and see if you can find the material you are looking for. So I'm going to narrow my geography here to Washington. You can either use the category tree or type it in directly here. So as you can see, we now have Washington State selected. I will click OK and then click search. I'll also note that we have done a really good job of tagging lightweight mixes versus non-lightweight mixes. That indicates the use of lightweight aggregate. So in this case, this means that we are not going to see EPDs for mixes that utilize lightweight aggregate. If I wanted to see both, I could remove that filter. If I only wanted to see EPDs with lightweight aggregate, I would say yes. So let's search. And here's that box plot and whisker diagram that I showed you before. And if we scroll down, we can see that there are 950 product-specific EPDs for 4,000 PSI mix in the state of Washington without lightweight aggregate. And here you can also see additional filters that are applied. For example, I'm only seeing EPDs that are valid after today's date. If you wanted to see EPDs that may be expired before today, you could remove that filter. And further, you can further narrow your search results if you know the specific manufacturer that's supplying concrete to your project. Let's say it's Cal Portland. I could use this filter to only see mixes from that manufacturer. You can just remove it by clicking the X. A couple other quick features I'll show you here is that you can sort from lowest to highest or highest to lowest GWP if you'd like to just, sometimes I like to see for fun what's the lowest carbon mix based on my search results. So you can just click on these arrows and looks like that is giving us the lowest carbon mix. And then if I click it again, it'll sort the results from highest to lowest. Really quickly, I do want to point out that anyone can upload an EPD to EC3. You can do that by clicking this Add EPDs to EC3 button and then import EPD from PDF. And then you can upload the PDF directly from your computer. It will take at least a couple of days for our systems to what we call parse the PDF EPD. Basically, our computer systems are trying to translate the information in that flat PDF into a digital format. And one of the initiatives that we've been working on is something called Open EPD, which is a digital format for EPDs. Some of the program operators here in the US have adopted that, and essentially it makes the transfer of new EPDs much easier into databases like EC3 so that you don't have to wait for that sort of parsing process of PDF copies of EPDs. Also want to point out the report bugs and feedback feature you'll notice on the bottom right of your screen in EC3. If you ever have a question or you encounter a bug or you'd like to propose an improvement to the tool, you can do that using this user snap feature. You can draw our attention to a certain area of your screen, and then you can tell us if you have a bug, an EPD or PCR problem, an improvement, or a question, provide some details, and then click submit. Our entire team receives those. Václav does a great job of managing those, and you'll probably hear back from him or someone else from our team and respond to your inquiry. All right, just a couple of other things here. I mentioned earlier, we do have some resources within the tool around our methodology that we use in EC3. So we do have this introduction to EC3 uncertainty, and then some information about the CLF baselines here. And then we also have this how to get an EPD feature. This is great if you're working on a project and you're dealing with a manufacturer that doesn't know what an EPD is. They don't even know where to get started to pursue EPDs. So I'm going to click, well, first here is just some basic information about what EPDs are and the process to get them. And then if you click on product EPDs, we've actually created a database of consultants and program operators who are involved in publishing EPDs. Let's say you're working with a ready mix supplier who doesn't have EPDs yet. We're going to select the ready mix category. And here you can see program operators such as ASTM and NRMCA are included. And then sustainability consultants who actually generate EPDs such as Climate Earth and WAP are listed here as well, along with a link to their website. So just wanted to point that out as a resource for you and your project teams who need to develop EPDs. All right, let me just check my list here. Okay, let's talk about creating new projects. So you're going to do that in plan and compare buildings. Just showing you quickly what each of these subfolders means. My buildings will be any project that you yourself have created. Templates are just that. We have published a commercial building template in metric and imperial units, which you can choose to use as a starting point if you don't want to start with a completely blank project. Shared with me will be any projects that another user has shared with you. You can collaborate within a singular EC3 project. Let's say there's a GC and a design firm and perhaps a sustainability consultant that are all collaborating to generate the EC3 model. The person who created the project can share it with other users. And if it is shared with you, it will show up here in this shared with me folder. We also have a number of projects that have been made public. This is a combination of example buildings that we have created here at Building Transparency. As you can see here, there are a number of different mid-rise projects, some tally import examples, high-rise projects, interior projects, so on and so forth. We also have templates and public buildings. So anyone can choose to anonymize and publish an EC3 project that they have created just to share that information and data with the general public. And those projects will show up here. So if you're interested in perhaps comparing a project that you created with another project in here that you find might have a similar scope, you can do that. We also have a number of templates. And here recently, we've actually started using this template feature to generate templates for the use of public policy. So as you can see here, we have reporting templates for New York City's Executive Order 23 and New York State's Executive Order 22 that we've made public to support their reporting purposes. You can create a copy of any of these projects if you want. And you can do that by clicking on this button that looks like two stacked pieces of paper. So if you find a project in here that looks very similar to a project that you're working on, or if you just want to play around with it, you can create a copy in that way. Just for the sake of the demonstration, I am going to create a copy of this BT commercial core and shell concrete example, and that will initiate the copy. And now our copied building is going to show up in our My Buildings folder. I'm going to go directly there by clicking this button. Sometimes it takes a while to think and load. Need that Jeopardy background music right about now. Okay, let's try another way. Oh, there it is. So I just went to My Buildings. There's that copy of BT commercial. Here's the copy of the template we just created. So first I'll show you just some of the basic project fields. The project name, you can replace this and call it anything you want. Under building use, this is where you'll enter your floor area above and below grade. You can also assign building use types here. If it is a multi-use project, you could assign a certain percentage or square footage or square meters to each building use case. And also enter the construction start date and the address of the project here. There is a section here for any just notes that you want to enter. This may be things that you, anything you want really. It could be notes to other people that you're collaborating in the project with. You can also link to attachments. Sometimes it might be useful to link to a bill of materials or something else here. There are also a number of building classification fields here, and this is really where, addressing the question that someone had earlier about infrastructure. If we were to upgrade EC3 to be more applicable to infrastructure, we would need to define sort of infrastructure classification parameters. So as you can see, there are a lot of things here that are really buildings focused currently. All right, so we're going to scroll down here, and this is where we're going to enter individual materials and quantities and select EPDs, or what we call map collections. So right now I'm looking at A1 through A3. So these are those upfront product stage emissions. And there are tabs for A4. Those are the transportation emissions between the point of manufacture to the job site. And then A5 construction phase emissions are associated with construction activities on site. So let's start with A1 through A3. As you can see here in this template, we have a number of different materials already populated. You can view in uniformat. You can view these in master format. You can also create a custom view if there is a specific way that you want to organize your materials. I'm going to stick with uniformat for the demo today. And first, I will show you the process of just entering a new material line item. So you will click on this Add New Element button. And one thing I'll point out is that we have built in tooltips throughout the tool to help you learn how to use it and how to navigate things. So as you can see, I just hovered over this button. This prompts me to add a new element. I would encourage you to kind of scroll around and just hover over different things and see the tooltips that appear to help you become more familiar with the features in the tool. So as you can see here, I just added a new building element. This is in my foundations section. So I'm going to just enter here foundation concrete. Let's say it's a 6,000 PSI mix. You can enter as much or as little information as you want. This field is purely based on user input, so you can describe the material in whatever format you want. Sometimes we'll see that private owners will have a specific format that they will communicate to you as far as how they want these materials organized and described in EC3. So I'm going to here enter my quantity. So let's say we have 2,000 cubic yards of this material. Now I'm going to click on this EPD button, and this is the exact same look and feel of the find and compare materials feature that I showed you before. So what you'll do is you'll navigate to the appropriate material category. I know this is ready mix concrete. This is a 6,000 PSI mix. And one thing that's different about assigning EPDs and collections within the building project planner is that we have specified an address for our project. In this case, I think it's Oakland, California. So what I can do is I can actually search for products that are within a certain radius of my project address. So let's try out that feature and see what EPDs we get within a 30-mile radius of Oakland, California. Okay, it looks like we have a little over 1,700 EPDs that met our search criteria. Now, if you know the actual product that's being used on your project, you can select it here from the search results. If you do not know, you can simply click use this collection, which will default essentially to the conservative value of our search results. So if you're doing this earlier on in design or in procurement and you don't know the exact product that is going to be used, you don't have to select it yet. We can just click use this collection. Just for the sake of the demo, I'm going to select one of these EPDs by clicking on the star and then selected. As you can see here, it turns a teal color and moves to the top of the list. So now I'm going to click use this collection. And as you can see here, now we have ready mix populated here where before there was nothing. And then if I toggle over to selected, you'll be able to see the actual EPD and the mix ID number of the product that we just selected. So you will continue to do that for every material that you want to model in EC3. If you're working with a specific owner or policy, they may dictate exactly what material categories they want you to model. So just make sure that you are complying with the relevant owner, public policy, or commitment or certification program requirements. Okay, make sure that you save your work. There is no autosave feature in EC3. I can do that up here at the top of the screen by clicking save and then save again, or save and close if you're done working in the project for the day. Okay, now I've got confirmation that my work has been saved. If you click on this private button, this is where you can share the project with other EC3 users. And actually, if somebody does not have an account yet, you can enter their email address and it will send them an invitation to join EC3. Here's that anonymize and publish button I mentioned before. If you would like to share your EC3 building project publicly, you can do that here. And then I do want to point out this gear icon. This is where you are able to actually set the reference line or the specific version of the CLF baseline values. So here you can change from 2019 to 2021 or the 2023 industry average CLF baselines. I do want to point out that the methodology in 2023 CLF baselines changed from previous years. In previous years, in 2019 and 2021, the baseline values were based on the 80th percentile, roughly, of material categories. This year, they've actually changed to industry averages. We do have some information and documentation on our website that explains the changes in methodology and how we have approached incorporating them into EC3. So if you're interested in reading up more about that, we can send you a link to that information. You can also set a GWP target. So you could either say that the target for my project is the EC3 achievable target. So that's those 20th percentile. You could also say below the CLF baseline by 20%, for example. So there is some flexibility here in defining what your goals are for the project. I'll show you a couple of things. Once you've entered all of your material quantities and either mapped your collections or selected your EPDs, there are a number of different charts and reports that you can generate. So here, some of you may have seen the Sankey diagram. It's the first available chart in EC3. It might be a little overwhelming at first. It was a little overwhelming to me the first time I tried to explain this to an owner, but over time, it's a very useful way to communicate a lot of information visually. So just starting here from the left, essentially what this is showing us is the contribution of embodied carbon of each individual material that we have modeled. So we can easily see the materials that have a taller bar here, or a taller color essentially, are the materials that are contributing more embodied carbon to the project. This is a useful tool when you are trying to get more bang for your buck, or try to focus your efforts on the materials that are going to reduce the overall embodied carbon of the project. So for example, we might not spend a lot of time trying to procure a lower carbon drywall. Of course, we should if we can, but really we should be focusing our efforts on procuring a lower carbon rebar steel or ready mix concrete, because those are materials that are contributing more to the overall embodied carbon of the project. And then as we flow from the left to the right, it's showing us contributions by individual material, contributions by system and subsystem, and then trickling over in here on the far right to the total building. So as you can see here, we've got the top line is our conservative estimate. The bottom is net zero embodied carbon. Here's our achievable. So as you start to actually select EPDs, just in the case that we did before with our 6,000 PSI mix, you will see this S and this blue bar that shows you the GWP of that specific product in relation to the conservative and achievable for each material. You can save this and use it in presentations or proposals. I'll quickly show you some of the others. I want to make sure we save some time for questions. I'll point out the LEED bar chart here. If your project is pursuing the LEED pilot credit for procurement of low carbon materials, we have built in the reporting requirements and this nice visual bar graph that meets the requirements of that pilot credit. Reports is where you can download Excel reports. There are a number of different options here. Most commonly, we see users using the building element report. So I'll quickly show you what that looks like. And it just opened up here. You can drag it, another screen. There we go. Oh, there it is. So as you can see, this is a detailed list of all of the materials, the quantities, the master format CSI division, the reference line total. So this is based on material quantity multiplied by basically the CLF baseline year that you selected, the conservative estimate. So that's the material quantity times the 80th percentile. Realized is material quantity multiplied by the GWP value from the EPD, the uncertainty adjusted GWP value. And then we also have achievable. So that's again multiplied by that 20th percentile or achievable target. So often we'll see users basically use this and generate any number of visuals and graphs and reports that they wish. All right, seeing that we have 10 minutes left, I am going to pause here and see what questions we might have.
Katie, there were a couple. Karen asked about identification of product specific versus industry EPDs in the search.
Yep. Question. So I'm going to go back in here to my previous example. By default, the product specific EPDs will appear as a list. You can open the industry-wide EPDs here. And you'll see all of the industry-wide EPD data that's actually contributing to the box plot and whisker chart? Good question.
Just a note, it sounds like one of the links on the PDF for the quality assurance doc, Václav updated in the chat, but we'll get that amended and included in the follow-up resources to the registrants at the back end of the event here.
Great. See Jessica's question about Executive Order 23. Are there EPDs in the EC3 database for low carbon concrete? Good question. That's a great segue into one more feature I wanted to show you, which is our policy compliance filters. I know New York State has published some GWP limits for concrete. I wasn't sure about New York City. So for Executive Order 23 and 22, right now, they're just requiring reporting of material quantities and EPDs. I don't believe they've set limits for concrete. But please let me know if I have that wrong. But when a policy publishes new GWP limits for specific material categories, we are building in policy compliance filters. So for example, Buy Clean Colorado just published their GWP limits in January of this year, and we built in a filter. So if you apply this filter, let's say for 6,000 PSI mixes, I'm going to remove my max distance from the job site, and let's click search. And hopefully this works. In theory, it will only show us concrete EPDs that are at or below that GWP limit. And it looks like there are 37 products that are compliant with that policy. In addition to Buy Clean Colorado, we also have the FEMA IRA funding. So if you're working on a FEMA project that is eligible for funds to pay for low carbon materials, you can apply these filters. Similarly, we have the GSA IRA limits. If you're familiar with that policy, they've implemented sort of a tiered approach where they're trying to procure the best 20% or lowest GWP 20%, however you want to say it, as a first option. And if those best 20% materials are not available, they're defaulting to the best 40%. And if those are not available, they're allowing better than average. So that's how we have those filters broken out here. We are working on adding the Cal Green prescriptive pathway limits. I believe that policy goes into effect in July. So we're going to try to have that filter live by then. Okay, seeing we have just a few more minutes, I wanted to briefly address one thing in the agenda that we said we would, which is just some general tips for integrating EC3 into your workflow. We have a number of free resources on our website, such as sample specification language and bid template contract language that you could incorporate into your specs or contracts that advise on language on how to require EPDs, how to set GWP limits if you choose to do that. So we can share out some of those resources from our website as well. And then very quickly, I did mention the LEED procurement of low carbon materials pilot credit. You can get 1 point just for doing the EC3 analysis for free, and you can get 2 points by demonstrating a 30% reduction from the 2021 CLF baseline values. I have personally used this pilot credit on a LEED project in the past. We were scrambling to try to find some points at the end of the project. So just know that this is a really, pretty easy, free, low-hanging fruit points on the table. I talked about our policy compliance filters. And I think just to wrap things up here, and Václav mentioned some of this earlier, but make sure you start a project going into it fully understanding what the goals are and establishing concrete goals for the project. Are you pursuing a specific commitment or certification program credit that you need to follow their requirements to achieve? Is this for a private owner goal or requirement in the specifications? Is it for public policy compliance? And in some cases, there could be more than one of these goals at play on a given project. So just make sure that everyone on the project team is fully aware of those individual requirements before you start this process. And then finally,
Václav, are you still on the call?
Yes, I'm still here.
Looks like
Seems
Katie
like
froze up on us.
So,
Katie, you're still with us?
yeah. Can you hear
Okay,
me?
yeah, you froze up for a
You're back.
second. You
Oh,
said
no.
finally, and then it froze. So whatever
Oh,
came after finally, we're ready for.
okay, great. I guess I was just going to end with some tips for embodied carbon reduction and say that the responsibility for reducing embodied carbon and achieving sustainability goals doesn't rest on one party's shoulders. It's not just the GC's responsibility or the owner. It's really an all hands on deck process. So at the beginning of a project, make sure you are determining team roles and responsibilities and talking about embodied carbon. Um, Ask your subcontractors to bring their ideas to the table for ways that they think you can reduce embodied carbon that are um, pertinent to your specific project, and bring them on board as early as possible. I always like to suggest that with projects that have very ambitious embodied carbon reduction goals, if you can bring on especially the structural subcontractors as early as possible, maybe even in a design assist capacity, we want those contractors on board at SDs or DDs at the latest in an ideal scenario. Of course, ask for those EPDs to be submitted at time of bid and ask for low carbon alternates in your bids. You know, think of this as a carbon value engineering exercise. And then finally, document those as-built quantities and products in EC3. I think a lot of times we see whole building LCA or EC3 models that are being done during design or in procurement, and it's sort of an ideal scenario, but as we know, things always change during construction. So we really need more data to confirm what's actually happening in real life, which is the real carbon that's being emitted into the atmosphere. So consider doing some final sort of true up of your EC3 models with as-built quantities and EPDs. And then finally, here are some links to some of those additional resources that I mentioned earlier and some other recorded videos and demos that you can utilize. And we will make sure that all of these links and maybe a PDF to the slides are sent out after the call. All right, I think we've got 4 minutes left. Are there any other questions or just general discussion?
If
See
not,
any more.
Katie. Václav, I don't know if you have any closing thoughts.
No, just thank you for having us. You know, we are here accessible to anyone. If you have any additional questions after this boot camp. So yeah, thank you, Katie, for sharing that. Here's our email addresses. Feel free to reach out. Also, feel free to use the report box and feedback section in EC3. Yeah, I think that's all. Thank you for having us.
Yeah, just jump in real quick. So I'm representing the Carbon Leadership Forum, Hub of Wisconsin. Ben Austin here again. I just want to give a virtual round of applause for Katie and Václav. They graciously gave us their time and their expertise. I know as I was maybe doing some housekeeping things, I'm going to be coming back to this recording and trying to take all the lessons you shared today and put into practice. So look forward to the continued conversation. But thanks so much for the detailed look today. Like I said, there'll be some follow-up resources that come out, and I'll make sure I work with Katie and Václav to pull those. Feel free to reach out to myself, other members of the Carbon Leadership Forum Wisconsin Hub. If you're outside of Wisconsin, right, check in to see if you have a local hub that you can engage with. If not, start your own. But Building Transparency is a great organization, great resource, and has got some great tools. So engage with them moving forward as well. Hope everyone has a good rest of your day, and talk to you next time.
Thanks,
Thank
everyone.
you.
Thank you.